My name is Samantha Uhler, and my partner is Anthony Dangio. And for our IE312 final project, we're going to discuss conventional plastic injection molding, also known as cold runner injection molding, and hot runner injection molding. Throughout this presentation, we're going to talk about the capabilities, advantages, limitations, and costs of plastic injection molding and hot runner injection molding.
So the capabilities between plastic injection and hot runner injection molding are as follows. For plastic injection molding, it is very cost effective in medium to small quantities. The molds and maintenance startup are expensive, but they are not as expensive as hot runner molding systems. As for material versatility, it is very easy to change the color and material of the final products. With complex geometries, it is pretty good with creating certain complex geometries, but when it gets too complex, it starts to have some flaws. The main difference between plastic injection and hot runner injection molding is the use of a runner. For the plastic injection molding, it uses an unheated runner, whereas a hot runner injection molding uses a heated runner. For small startups, it is a very good idea to use plastic injection molding as the startup costs are very small. For hot runner injection molding systems, there is a high degree of tolerance, which means that your final part will be very consistent and very precise, even when creating very complex products. A hot runner injection molding system is very good for large quantities, and it has a very quick cycle time, which it allows it to create many parts in small time frames. The whole point of a hot runner injection system is that it has a hot runner that keeps plastic hot as it fills the mold, which evenly allows the plastic to spread within the mold, getting into small nooks and crannies where plastic injection molding might not be able to.
So for the advantages of plastic injection molding, we have low maintenance costs because it's simpler design and it has less components. There's a large variety of materials and colors, and since heat's not being used, you don't have to worry about the product's color bleeding or the heat sensitivity of the product. They are resistant to wear. Like I said, there's few moving parts and they don't require much maintenance. It's better for smaller quantities because it's inexpensive and it's easy to set up. There's that low initial starting cost. And there's quicker changes for product modification. So once again, it's a simpler design, so it's a lot easier to modify. For hot runner injection molding, it produces better part tolerances since you can control the pressure and the temperature of your material. There is very little waste because, as Anthony said, you don't have to discard the runner after each cycle. Similarly, there's a large product volume size because you don't have to remove this runner. And not having to remove the runner requires little maintenance, so it decreases the maintenance costs.
Some limitations for both plastic injection molding and hot runner injection moldings are as follows. For plastic injection molding, it is more prone to create waste over hot runner injection molding. For large quantities, plastic injection molding is not very efficient, and because it has a slower cycle time, which means that it creates large quantities in drastically longer times than hot runner injection molding. For the tolerance within plastic injection molding, they have a wider range, which means that the precision of plastic injection molding is less than hot runner injection molding. The very complex parts, as I mentioned earlier, and parts that have very large volume are also very difficult to create using plastic injection molding. Now for hot runner injection molding, if you would like to have a startup and you would like to purchase these hot runner injection molding systems, they are very expensive. They also have a low variety of materials to choose from, as some materials cannot be used in hot runner injection molding as easily as cold runner plastic injection molding. For the final product color, as Sam mentioned, it is pretty difficult with color bleed to get hot runner injection molding to have the final color that the customer or specifications would want. And for small quantities, it is not very effective to use hot runner injection molding because it will cost more to run the machine and have the machine to create small quantities than if you were to allow it to create large quantities.
So for the costs, plastic injection molding has a lower initial startup cost than hot runner injection molding. Hot runner injection molding is cost effective only in large quantities because there's a very short cycle time, so the products are produced more efficiently. Since there are less components to cold runner injection molding, as I've said before, the maintenance cost is usually lower than hot runner injection molding. And the complex parts in the hot runner injection molding machines have additional running and maintenance costs.
So why should you make the switch from cold runner injection molding to hot runner injection molding? Some common questions would be, what product types should use hot runner systems? For these product types and specifications, products that are very complex or have high volumes or that orders call for large quantities, it would be more effective to use hot runner products or hot runner machines because they have very fast cycle times, which allow them to create very large quantities of parts. They have a very good flow of material, which allows them to create very complex parts that have very thin, long, complex geometries. And since they can flow easier, they are also very good at creating high volume parts. What modifications to machines and toolings need to be made to switch from cold runner to hot runner injection molds? There is quite a bit to be done to upgrade your machines to hot runner injection molding. For the most part, you would have to you would have to create certain plates. You would need to buy wires and assemblies, buy the part itself. You need to add manifolds and nozzles to make the machine capable of using hot runner injection molding software. Most of the time, you would need to create custom plates, which could add to the cost of the machine, as buying a custom-made plate would require someone to put some CAD software and have to design the plate themselves, which might be a little expensive. So that segues into my next question. What are the costs to upgrade from cold runner machines to hot runner machines? So the specific part that we are looking for in general is made by Husky, and it is around $12,000 to $17,000. Now, this is around the mid to high range when it comes to hot runner injection molding. And this specific runner and injecting molding is $4,500. This is a quote that we got from a hypothetical company for them to install this part and make sure that it integrates well with your system software and different system capabilities. What improvements in yield and in trimming costs can you expect when you purchase an upgrade to a hot runner injection molding machine? Specifically, for trimming costs, you can see that there's going to be no excess runner materials. So either having robotic arms or robotic automatic machines that get rid of these runners, or having actual employees that get rid of these runners, those would not be needed because they do not create excess running materials like that. There is a large cycle time, or there's a very short cycle time rather, in hot runner injection molding machines. So you would be able to produce a lot more parts. So you would need less machines to create the same amount of product. So that is another trimming cost. And there is also less defects when it comes to hot runner injection machines, which means that you would have less waste, which is also another trimming cost. Now, for some yield costs that you can expect is as I said, there is less waste, so there would be less yielding costs that way, and there will be a larger quantity size. So you can create more product, even just creating the same amount of product, needing less machines. You can just create more product with the same amount of machines. So your yield cost would be less.
And these are the resources that we used for our presentation. Thank you.